last part, 6, 5, 6, 6 should be done. Remember the properties of logs. When you have a log of a product, meaning multiplication, you can split that up into the sum of two logs, addition of two logs with the same bases. And if you have a log of division, you can split that up into the difference, meaning subtraction of two logs with the same bases. And anytime you have a log with something inside with a power on it, that power can come out as a multiplier in front of the log. So we could use the fact that log base 7 of 4 is 0.712. Log base 7 of 12 is 1.277. And the trick is writing this in terms of 4 and 12. So we can write this log base 7 of 12 divided by 4, which is log base 7 of 12 minus log base 7 of 4. And then we can just use these decimals. 1.277 minus 0.712. We get the answer. It looks like it's 0.565. Okay, so the next one, we've got log base 7 of 64. We can rewrite that as log base 7 of 4 to the third power, because 4 times 4 times 4 is 64. And that's 3 times log base 7 of 4. And then we can replace the log base 7 of 4 with 0.712. And get the answer. .136. Okay. Now, if this is a multiple choice test, you probably could use log base, like log base 7 of 64. Log bases of math, log base 7 of 64. And you get 2.137, which is the real answer. And it's pretty darn close to 2.136. And if it's multiple choice, that might be enough. I doubt that the choices in a multiple choice test are like 1/1000th away from each other. If they are, then you really have to use what they give you. But if they're not, then you can just use log base and get the answer. I'm just thinking out loud. So expanding this, since it's a product, we can expand that in log base 3 of 4 plus log base 3 of x. Expanding this one, we've got multiplication on the top, and then you divide by y to the 4th. Everything in the denominator is going to end up being negative. So we've got the natural log of 6 plus natural log of x squared minus natural log of y by 4. And then these powers can come out first. Natural log of 6 plus 2 times the natural log of x minus 4 times the natural log of y. And then if we're condensing it, this subtraction, we can write it as 1 log base 4 of 7 divided by 10. And if we're condensing it, each one of these coefficients we can use as a power. So we have the natural log of x to the 6th plus the natural log of y to the 4th. And now we can write this as just 1 log natural log of x to the 6th times y to the 4th. And that's inside the log. And we're at 6.6, last section. Well, this one's a little bit tricky because we want the bases to be the same. 5 to the power of x minus 3. But you can write 25 as 5 squared, power of x minus 5. And then when you have a power of a power, you multiply the powers. So this is the power of 2x minus 10. And now that the bases are the same, we can just set up the equation x minus 3 equals 2x minus 10 and solve that equation. So you subtract x from both sides to get x on the right and add 10 to both sides to get 7 on the left, and it looks like x is 7. And the next one, you have to undo the exponential with 3 to the x. And the way you do that is you log base 3 on both sides of the equal sign. And when you have the base of the log the same as the base of the exponential, that disappears, just leaving x. So x equals log base 3 of 7. And if we need to find a decimal approximation, rounded to the nearest thousand, that's 3 digits past the decimal place. Log base 3 of 7. So math log base 3 of 7. 1.771. Okay, since the logs are the same on both sides of the equal sign, what's inside is equal. 4x minus 7 equals x plus 11. So solving that should be simple. 3x on the left, and 18 on the right, and just divide by 3 to get x is 6. Quick glance to make sure that 6 doesn't make either log negative or 0, and they don't, so we're good. This one might be a little trickier because we want to condense this into 1 log base 2. And the way you do that is you multiply the x times the x minus 2. Which is x squared minus 2x. And now we want to get rid of the log, and the way you do that is use an exponential. In this case, it's going to be the 2 as the base. And we have this equation, x squared minus 2x equals 2 to the third power, which is the number 8. 2 times 2 times 2 is 8. And then subtract x from both sides and factor this. Right, we've got x minus and x. Well, if you need 2 numbers to multiply to a negative, they have to be opposite signs, so it's x plus. 2 numbers that multiply to 8 and subtract to 2 are 4 and 2. So the values of x we get are positive 4 and negative 2. Now we have to check and make sure that those numbers won't make what's up here 0 or negative. Negative 2 makes that negative and that negative, so it can't be negative 2. Positive 4 is the only answer. There we go. Last problem. Yep, legit. So 9 to the x equals 54. The way you undo an exponential is use a log, and you have to specifically use the log base 9. supposed to put a 54 there. So we're going to log base 9 on the sides. And on the left, you're left with just x. And on the right, oh, this is a greater than none equals. Nice. And relative answer to the nearest thousand. So log base 9 of 54 is a number. We can use a calculator to find it out. And it's 1.815. About that. Okay, and that's it. Good luck on the final exam.
Have fun.
Have fun, I guess. We're going to have fun. How could you not?